Hi teacher, hi everyone, I am Uber Medina. Today I want to take you on a little journey where we will learn and discuss semiconductors in the mid-20th century and the significant changes that followed their invention. First, it's important to understand what a semiconductor is. A semiconductor is a material that has electrical conductivity between that of a conductor, like metals, and an insulator, like ceramics. Semiconductors can conduct electricity under certain conditions but not others, making them ideal for controlling electrical currents in electronic devices. Silicon and germanium are common examples of semiconductors, widely used in components such as transistors, diodes, and integrated circuits. Research into semiconductors began in the late 1800s and early 1900s, focusing on the conductivity and electrical behavior of different materials, especially metals, and classifying these materials based on their conductivity. In the 1930s, research shifted specifically towards semiconductors, deepening the understanding of metal semiconductor junctions and the P-N junction, crucial to semiconductor technology, was discovered by identifying impurities in silicon that affected conductivity. This period also saw advances in thermionic emission, a key element in semiconductor function. However, the major turning point came on December 16 of 1947 with the invention of the first transistor. This device, known as the bipolar transistor, introduced new materials configuration called NPN and PNP that created three regions: the emitter, the base, and the collector, essential to its operation. The transistor was invented at Bell Laboratories in Murray Hill, New Jersey, USA. At the time, these labs were among the most advanced research centers in the world, supported by AT&T. Scientists and engineers that worked on solving complex problems in telecommunication and electronics, which fostered this invention of the transistor. The transistor was invented by a team of three scientists: John Barney, Walter Brattain, and William Shockley. Barney and Brattain conducted the key experiments that led to the first functional transistor, while Shockley, the leader of the research team, contributed to the theoretical framework and design of a more advanced version known as the Junction transistor. All three shared the 1956 Nobel Prize in Physics for their contributions. The transistor was developed to replace vacuum tubes, which were then used to amplify signals in radios, telephones, and other devices. Vacuum tubes were fragile, generated excessive heat, and consumed a lot of power, limiting their use in smaller, more efficient devices. The transistor, being compact and durable, solved these issues by improving the efficiency and performance of communication and signal processing technologies. The first transistor was made of germanium, a semiconductor material capable of conducting electricity under specific conditions. This property enabled semiconductors to act as switches or amplifiers for electrical signals. Over time, silicon replaced germanium as the preferred materials because it is more abundant, cost-effective, and resistant to high temperatures. Today, silicon remains the primary materials used in semiconductors, with impurities intentionally added to modify the material's behavior. The transistors solved the problem of large, expensive, and fragile components that limited the development of compact, portable electronic devices. Vacuum tubes, which were widely used at the time, had a short lifespan and required a lot of space and power, making equipment large and impractical. This breakthrough paved the way for the development of modern electronics, from computers to telecommunication systems. The invention of the transistor marked the beginning of modern electronics and the computer revolution. With the miniaturization of electronic components thanks to transistors, it became possible to develop smaller and more powerful computers, which accelerated the growth of information technology. Additionally, transistors made possible portable radios, televisions, and other electronic devices that transformed everyday life. Over time, this technology also led to the creation of integrated circuit chips, now found in nearly all electronic devices. Over time, this technology also led to the creation of integrated circuit chips, now found in nearly all electronic devices. The inventors of the transistors, Bardeen, Brightin, and Shockley, became world renowned for their breakthrough and received the Nobel Prize in Physics in 1956. However, the success of the transistor also caused tension within the team. William Shockley and John Bardeen had disagreements over the credit for the discovery, which strained their personal and professional relationships. Eventually, they went their separate ways. For instance, Shockley founded Shockley Semiconductor in California, which played a pivotal role in the rise of Silicon Valley, while Bardeen continued his research and later won a second Nobel Prize. Yes, the transistor is still used for its original purpose, to amplify and switch electrical signals. However, the application of semiconductors have expanded dramatically since their invention. Today, they are used in almost all electronic devices, including computers, smartphones, household appliances, automobiles, solar power systems, and many others. The inventors of the transistor faced numerous challenges, both technical and personal. Technically, they had to solve complex problems related to the physics of semiconductor materials and develop manufacturing processes to make the transistor viable. Working with materials like germanium was particularly difficult, as their properties were not well understood, and controlling the impurities necessary for proper functionality was challenging. On a personal level, disagreements between the inventors, especially between Shockley and his colleagues, created tensions that hindered collaboration. Shockley, for instance, pursued his own independent research on the topic, which contributed to further division within the team. Working with materials like germanium was particularly difficult, as their properties were not well understood, and controlling the impurities necessary for proper functionality was challenging. On a personal level, disagreements between the inventors, especially between Shockley and his colleagues, created tensions that hindered collaboration. Shockley, for instance, pursued his own independent research on the topic, which contributed to further division within the team.